Well, well, what has a cat dragged in today? It's the last video in the Meteors tutorial sequence. We're going to take a look at, in this video, is setting up two basic additions to the gameplay to make it just a tiny bit more interesting. Making the rocks move, and making it so that we can take more than one hit before losing. Let's deal with the rock moving first, because that might sound like a really complicated task to do, but it really isn't. Now, of course, this is a learning project, right? No one's going to be playing this, let's be honest. But taking it in the context that it is, it's a very simple game. And so we don't need to try to go for a really complex solution here. It's not worth it for what people would expect out of this project. I mean, we could do something crazy and use paths and gradients and have them do all sorts of cool curvy things, and have it so that as a rock goes off the edge of the screen, it teleports back over here and continues on traveling, sort of like how the actual game Asteroids does. All sorts of crazy complex things that we could do, right? But we don't really need to do that. Not here. As long as it feels like the mechanic, like the action belongs in this game, and it's interesting to the player, that's all that matters. We're in space. If all these rocks do is just sort of idly rotate around a point, that's not necessarily going to look out of place. And it gives just that little bit of mechanical complexity, just a tiny bit of mechanical complexity to make this learning game more interesting. That's all we're going to do. And that is really simple, as long as you understand how parent-child objects work in Unity. If I have children objects and I rotate the parent, the children rotate as well. So all I need to do is I am going to create an empty game object. I'm going to reset the transform and position it. So let's just say that I'll grab... Nope, not those. I'll grab this collection. Did a shift click on that last one there. I'm going to grab this collection of rocks, and I'm going to make them rotate around that empty game object that I added into the scene. And I've got two empty game objects in here because I forgot to clean one of those up. So let me get rid of the old one that I forgot to clean up. You didn't see that one. So there we go. This is the empty game object that I'm going to actually add things to. All right, let's get my rocks back. And I'm going to drag that selection of rocks onto this empty game object, making them children of this game object. I'm also going to rename this to rock rotate point. Now I also want some kind of visual just so I can see where this point is. Since it's an empty game object, of course, it has no visual representation in the scene. What I can do is in the inspector, there's this little Unity cube icon. If we click on that, we get some labeling options here. I could select a label that would actually have its name if I zoomed in close enough, be able to see it. But I'm just going to select a little diamond. That way I'm looking at it. I can see, oh, yep, there's my rotate point, and I can also click on it to select things. Something else that I'm going to have to do is I am going to have to put a rigid body on these. Currently, these are static. The static keyword has nothing to do with this definition. If you have a collider and you have no rigid body with that collider, it is a static collider as far as Unity is concerned. But these are no longer static. They're going to move. And so I need to put a rigid body on here. So I'm going to add component rigid body. Now, I don't want these attempting to interact with the actual physics system. You know, if they overlap and hit each other, or if they overlap and like hit the rocks on the side here, I don't want there to actually be a physics reaction to that, because that would get weird really fast. And so I'm going to make these kinematic. I'm also going to turn off gravity because I'm paranoid, but since I've marked them as kinematic, it doesn't really matter. By marking these as kinematic, I'm saying, yes, they're in the physics system. Yes, they can trigger a collision with this fully, simulated rigid body that is our ship, but otherwise they're not going to interact. So if they overlap each other, that's fine. Nothing bad's going to happen. Now I need to make sure this is applied to all of these rocks. So you can select all of them. Well, actually, I'm not going to select this first one because I already did this first rock. It's already been configured, so I don't want to select it. But I'm going to shift-click and select the rest of the rocks here. And I can add the rigid body on, turn off gravity, turn on kinematics. So now, all of these rocks are kinematic rigid bodies. As you can see, if I rotate the parent, the rocks come along for the ride. So all I need to do is I need to add a flow graph onto here to rotate this parent object. So I'm going to add component. I'm going to add on a flow machine. Now, this would be an actual good spot to use a macro, because I would use this on multiple different game objects with the exact same logic and the exact same performance. But I'm not going to do that for this video. I'm still going to stick with embedded and then just duplicate this game object. I'm going to call it rotation. I'm going to edit my graph. Don't need the start event, so I'm going to get rid of it. And all I need to do on update is I need to rotate. Anytime you're dealing with rotations, scaling, moving, that is going to be under transform. Sure enough, there we go. Transform, rotate. I just want to rotate it around the y-axis, so rotate it with y angle. So I'm going to choose the XYZ angle option here. Now, I do not want to just put a number in here, because then I would be rotating by frame, and there's very seldom any good reason for doing things per frame. We want to do things per second. And any time we're doing something per second, I'm going to need a time.delta time. I am going to multiply that by whatever degrees I want this to go by. So I'm going to try 20. Sounds like a good number. So basically 20 degrees per second. And I'm going to feed the resulting value into here. So let's see what that looks like. There we go. Of course, I want the others to rotate as well. What I will do is I'll just get rid of those. And take this and duplicate it out. Rotate each of them. Maybe shift the rocks around a little bit so it doesn't look quite so similar. And there we go. Now, a little bit of extra mechanics there. I have to put a little bit more thought into actually paying attention and dodging them. So great. I've added a little bit of mechanical complexity to this game to make it a little bit more interesting. And the visual effects of it, I mean, it's not bad. It's not great, but it's not bad. So there you go. That's moving rocks. Very, very simple. Also, very easy to overthink. Let's do a quick cleanup here. Let's get these yoinked back into the general rock collection. There we go. Now let's take a look at having our ship survive more than one hit. So I'm going to select my ship, and I'm going to want to edit the collision control flow machine. Let's go ahead and pop this into full screen. So here's where we have our logic for dying. I hit a collider and I die, because the only things that have collisions on them, not triggers, but collisions, are the obstacles. So I'm going to move this over to the side. Pardon me, over to the side, because I still need this logic at some point, but it's going to be later. And I'm going to right-click on that wire to delete it. Now the question becomes, how do I want to do this? Well, I'm going to need to track either how many times I've been hit or how much health do I have left. You can look at the logic either way. Anytime I have information I need to track, of course, I'm going to need a variable, because that's the whole point of variables, to track information. And so it's like, okay, I'm going to count down. So I'm going to say, let's say I've got shields. And I am going to allow the player to be hit 3 times. On the 4th hit, they die. So I'm going to have a shield count. I get hit. Do I have shields left? Is my shield's value 0? If my shield value is 0, then I die. If my shield value is not 0, I need to subtract 1 from my shields and then destroy the rock that hit me. That's mainly for visual, because it would look weird if the rock passes through the ship, right? So if I've got the ship's, let's just pretend for the moment this is the ship, and a rock comes through and passes through the ship and keeps on going and we don't die, the player's going to perceive that as a bug. The player's going to perceive that as a defect, even though it really isn't a defect, right? It's working as intended, but it's going to look weird. So don't want to do that. So destroy anything that we hit. So let's get that set up. Now, I'm just going to use a graph variable to track my shields. You could make an argument for making this an object variable, so that way it can be edited in the inspector. Of course, this is going to be an integer, whole number, right? And I'm going to set the value to 3. Like I said, I can take 3 hits. So now, on collision enter, I'm going to branch. In other words, I need to make a decision. Do I do A or do I do B? That's branching. So I'm going to drag this out. No, that's not it. Control, branch. What is my decision based on? Are my shields equal to 0? So I'm going to need shields. I am going to need to compare this. So I am going to go into logic and equal. I am going to need an integer literal. So I'm going to compare it to 0. So I'm going to say shields equal to 0. Oops, let's drag those down. Give myself a little bit more room here. Just like trying to keep my wires as clean as possible. A habit you would never guess from the condition of my desktop. All right, so now I have fed the equation in. So if it's true, well, I actually already know what to do if it's true. I die. But now if it's false, I need to subtract from shields. So I need to set the shields variable to a new value. So that will be the first thing I do. So graph, I'm going to set shields. What am I going to set shields to? I am going to set it to shields -1. Oops, that's just those. Thank you. So I'm going to say, all right, got my shields variable. I'm going to subtract from shields. I'm going to subtract 1. I'm going to set the shield variable to that. So now I've lost one of my shields. And now I need to destroy the game object that touched me, the rock. So, of course, that is destroy. Oops, and that's the wrong version of destroy. Destroy, this version here is to destroy an object in X amount of time. Useful if you know that something's going to play a death animation, or like, a corpse. A lot of games, you kill an enemy, their corpse falls to the ground, a moment passes, and then the corpse disappears, right? That's the kind of thing that you might use the time variant on. But no, I want this, bam, gone now. And not component, thank you very much. Game object destroy. Now, the question becomes, what do I pass into here? And that sometimes can be a little bit tricky. Let's try data, because the icons match, right? Oh no, that doesn't work. This is where knowledge of what is contained within objects, or within components and classes, becomes important. Because I know from having read the definition of what information is passed into on-collision-enter, I know that there is a collider. I know that the collider eventually contains a reference to the game object that caused the collision. Unfortunately, if I drag this wire out and I hook it up, it will link and I forgot that I was in full screen mode. But it's not destroying. Yeah, we're not getting any useful errors either. And, well, I died, as I should, but I'm not destroying the rocks. I wish it would actually give a decent error message here, but it just doesn't. This is one of those areas where if you don't know that you can get to a game object through the collider, you might not think of doing this. There is a very useful thing in Bolt where you can choose to expose something. And what that does, as you can see here, is it exposes everything about that particular class that is public. And, oh, hey, look, there we go, game object. There we go. Disappeared. 2, 3. I should die. And I did. And that's it. That's all we got to do. It's not very hard. The key thing when it comes to functionality, whether you're using Bolt, Playmaker, C#, whatever, is to think about the steps. Plan out the steps that you need to do the thing that you want. So it's like, okay, I've got shields, so I'm going to need something to track my shields. I need to ask the question, do I have any shields left? If I don't, then I'll die. And since I'm asking that, if this, else that, I know I'm going to need a branch. So, I've got shield variable, but if I do have shields and I get hit, then I need to make sure that I subtract from the shields and then destroy the game object that hit me. As long as you just take your time and think about it and break it down, it's really not that hard. And that concludes this video and the sequence for the Meteors game. If you found this video helpful and useful, a thumbs up would be appreciated. And if it wasn't all that great, well, the thumbs down button is right next to it. Until next time.